Okay, in this section, we're going to be working with the sum and difference formulas. We're going to find the exact values, first of all, for the sine of 195 and for the cosine of 5 pi over 12. For things where you are told to find the exact values, that is a key to know you want to use the unit circle. We don't want to be using our calculator. We want to be able to use a unit circle and unit circle values. The sine, we can use either the sine sum or difference. We can use cosine sum or difference depending on what angles we're going to be using. So I'm just going to write the shorthand formulas. Sine of u plus v is sine of u cosine v plus cosine u sine v, and sine of u minus v is sine u cosine v minus cosine u sine v. So the signs, the SIGN, the signs at the top go together and the signs at the bottom go together, and notice in cosine they are reversed. So the plus goes with the minus sign and the minus goes with the plus sign. For the sine of 195 degrees on the unit circle, let's use 150 and 45. Remember, the angles that you're using are 30 degrees, 45 degrees, 60 degrees, 90 degrees, or some multiple. Basically, it's a puzzle and you're just trying to figure out what pieces do you add together to get to 195. So if I started with 30 and I subtracted away 30, that would give me 165, which isn't on the unit circle. So then I could try 45. Let's subtract 45. That's going to give me 150, which is on the unit circle. That's going to be equal to the sine of 150 degrees, the cosine of 45 degrees, plus the cosine of 150 degrees, the sine of 45 degrees. The sine of 150 degrees is equal to 1/2. The cosine of 45 degrees is root 2 over 2. The cosine of 150 degrees is negative root 3 over 2, and the sine of 45 degrees is root 2 over 2. Multiplying straight across, we get root 2 over 4 minus root 6 over 4, or root 2 minus root 6 over 4. For the cosine of 5 pi over 12, remember you're working with pi over 6, pi over 4, pi over 3, and pi over 2. So you have to think about what pieces come together to make it 5 pi over 12. If you found a common denominator for these, that is 2 pi over 12, 3 pi over 12, 4 pi over 12, and 6 pi over 12. And that helps you come together for 5. I see that 2 pi over 12 and 3 pi over 12 would work for me, so I can use pi over 6 and pi over 4 here. The cosine of pi over 6 plus pi over 4 is equal to the cosine of pi over 6, cosine of pi over 4, minus sine of pi over 6, sine pi over 4. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. Multiplying straight across, I get root 6 over 4 minus root 2 over 4, or root 6 minus root 2 all over 4. Our next question asks us to find the exact value of the expression, but we don't know 99s and 36s. So what we want to do here is we want to look at, first of all, what formula can we use to get there, and what number am I talking about? Let's recall the sine and cosine sum and difference formulas. We have cosine cosine and sine sine, which matches the cosine formula. And we have a subtraction sign, which means we're going to be dealing with plus. So this is going to be the cosine of 99 degrees plus 36 degrees. 99 plus 36 is 135. We are looking at the cosine of 135 degrees, which from the unit circle is negative root 2 over 2. If we have the cosine sum of alpha plus beta, that's the cosine alpha cosine beta minus sine alpha sine beta. I then need the cosine of alpha, the sine of alpha, the cosine of beta, and the sine of beta. And so based on the sine and cosine they've given us, we're going to need to draw this and figure out what those values are. I'm going to draw two different triangles to represent the situation we have here. Okay, first of all, we are told that alpha is in quadrant 2 and beta is in quadrant 4. And remember that these are always angles in relation to the horizontal axis. So I'm now going to draw a triangle so that I can then fill in the components that we have. Alpha's sine is 5 over 13. That means that opposite is 5 and the hypotenuse is 13, which means we need to figure out what the x value is. It's in the second quadrant, so it's going to be negative. Cosine of beta is equal to 5 over 6, which means we have the adjacent is 5 and the hypotenuse is 6. We need to find the y value, which again in the fourth quadrant is going to be negative. So let's use the Pythagorean theorem to find those values. X squared plus 5 squared is equal to 13 squared, and so x is going to be the square root of 13 squared, which is 169, minus 5 squared, which is 25. X is going to be the square root of 144, which is 12. That's a Pythagorean triple. Hopefully you start to recognize that. And it's negative because it's in the second quadrant. In this case, for the hypotenuse on the fourth quadrant, 6, there's no something something 6 triangle. There's no something 5 6 triangle. So we're going to get a radical in this expression. So what we have here is y squared plus 5 squared equals 6 squared, or y is going to be equal to the square root of 6 squared minus 5 squared, which is 36 minus 25. And so y is going to be equal to the square root of 11, and it's negative. Okay? We have the sine of alpha, we have the cosine of beta. We need the sine of beta and the cosine of alpha. The cosine of alpha is going to be negative 12 over 13, and the sine of beta is going to be negative root 11 over 6. Let's go ahead and find the exact value then using our formula. So the cosine of alpha plus beta is going to be equal to the cosine of alpha, which is negative 12 over 13, times the cosine of beta, which is 5 over 6, minus the sine of alpha, which is 5 over 13, times the sine of beta, which is negative root 11 over 6. Multiplying straight across, we get negative 60 over 78 plus 5 root 11 over 78.